Hello, 8th graders. So today we are still working on Chapter 15, which is Molecules and Compounds. So far in Chapter 15, we've talked about the difference between compounds and mixtures. We've talked about chemical bonds and why they form. We've talked or reviewed chemical formulas and how to determine the number of atoms in each chemical formula. And then we talked about electrons, mainly the valence electrons and their role in chemical bonding. That octet rule, remember the 8 electrons. And today we're going to start predicting chemical formulas. I'm going to let you know right now that this is usually one of the most complicated or confusing lessons for 8th graders. That's okay. We're going to try to break it down as simply as possible and try to get you all to understand. If you are still unclear at the end of this lesson, please reach out. We can set up a Google Meet or whatever you might need to help you become more confident with this. After the next lesson, not today's lesson, but the next 2 lessons are going to focus on this target, which is I can use oxidation numbers to predict molecules. Today, by the end of this lesson, you should be able to determine the oxidation number of certain atoms. On our next lesson, we're going to talk about how we use that oxidation number to predict different molecules and how they'll bond and form. So today, by the end of today's lesson, I want you just to be able to identify an oxidation number. So let's first do a brief review. Chemical bonds are formed between electrons in the valence shell, in the outermost shell. These are called the valence electrons. The reason that atoms bond is to reach that maximum stability and the lowest energy state possible, which happens when they have a full outer shell of electrons. I would also like you to understand Lewis dot diagrams because that's going to be helpful. So let's just briefly review those. For Lewis dot diagrams, what you do is you find the element on the periodic table, you determine the group number, and that will tell you how many valence electrons that element has. Some examples here. Neon is in group 18, so it has 8 valence electrons. Fluorine, group 17, so it has 7 valence electrons, and this is how you would draw them. Oxygen has 6, nitrogen has 5, carbon has 4, boron 3, beryllium 2. That is not how that should be drawn though, but beryllium 2, lithium 1, and hydrogen 1. So just as a reminder about Lewis dot diagrams. All right, so let's talk about oxidation numbers. And again, this is the most confusing part for many 8th graders. Just bear with me as we go through this. You will understand it. Just kind of stick with it. So an oxidation number basically indicates the charge on an atom when electrons are gained or lost or shared in chemical bonds. So let's go back to our Lewis dot diagram really quick. So in our Lewis dot diagram, these represent the electrons. And currently this is a neutral atom, which means it has the same amount of protons in the nucleus as electrons in the electron shell. Let's work with fluorine here. In order for fluorine to become stable, it needs to fill up this outer shell, so it would take on 1 electron. When it takes on that 1 electron, well, now it's no longer a neutral atom. It has more electrons than protons. And we need to remember that protons have a positive charge, positive, and electrons have a negative charge. So when fluorine forms a bond to become stable and it takes an electron, it's taking on 1 additional negative charge. So we say now this atom has a charge of -1. Lithium, on the other hand, it has a choice. To have a complete outer shell of electrons, it can either take 7 electrons or it can give away 1. And we find that it's much easier for lithium to give away 1 electron than it is to take 7. So when lithium goes to give away an electron, well, now it has more protons than it does electrons. So it's going to have a positive charge of 1. So its oxidation number would be positive 1. All right, let's keep going. Stick with me. I promise you'll get this. So this slide takes sodium, Na, as an example. Sodium has 1 valence electron. So when it wants to get stable, it has its choice. It can take 7 electrons or give away 1. Which would be easier to do? Well, giving away 1 electron would be easier. So that would leave it with 1 extra proton in its nucleus, which would give it a positive 1 charge. So therefore we say sodium has an oxidation number of 1. This chart is very, very helpful because it tells you their actual oxidation numbers. And let's explain why that's an oxidation number. So this is group 17 right here. So all elements in this column have 7 valence electrons. Now, to become, let's take fluorine, for example, here. Fluorine has an atomic number of 9. Atomic number means it has 9 protons in its nucleus. With its 7 valence electrons, it has 9 electrons. Now, it is hard to get rid of 7 electrons, but it is easy to take 1 electron. So to become a full shell, fluorine will take 1 electron. That means that it will now have 10 total electrons and 9 protons. So it has a negative 1 charge, or an oxidation number of negative 1. Let's do boron here. Boron has 5 protons and 5 electrons. In its outer shell, it's in group 3, so it has 3 electrons in its outer shell. To become an octet, to get that full outer shell of 8 electrons, it can either take 5 electrons or give away 3. And atoms are going to want to do what's the simplest. It is easier to give away 3 than to take 5. So it will give away 3 electrons, which will leave it with 2 electrons and 5 protons. So its oxidation number would be positive 3 because that's the current charge of it. Now, these elements in group 4 act a little strange because carbon, for example, carbon has 4 valence electrons. So to get to that full outer shell of 8 electrons, it's going to have to either give away 4 or take 4. Well, which is easier? They're both the same, right? Because the number's the same. It's 4. So a lot of times we'll say the oxidation number, this chart shows it as positive 4, but usually we show it as positive or negative 4 because it's the same amount to give away or take. It's easier if you have less than 4 electrons in your outer shell. It's easier to give them away than to take. And if you have more than 4 electrons, it's easier to take electrons than give away to get to that final 8 octet. Okay, I hope that made some sense. This is where we're going with our next lesson, but I just wanted to show you so it makes sense. When we use oxidation numbers, and lots of periodic tables will actually show the oxidation number in the periodic table. But when we try to predict molecules, what we have to do is the total charge has to add up to 0. So when you add all the oxidation numbers of each element, it should come to 0. So here we have carbon dioxide, CO2. Carbon, if we go back to this chart, has an oxidation number of 4, positive or negative 4. Whereas oxygen has an oxidation number of 2. So carbon dioxide with 2 oxygens will form because positive 4 plus a negative 2 plus a negative 2 equals 0, which is why there's 2 oxygen here. So carbon dioxide forms because the oxidation number adds to 0. This chart is going to be your best friend. This chart tells you what their oxidation number is. I just want you to understand that oxidation number comes from how many electrons They're giving away or taking. And that's because electrons have a negative charge while protons have a positive charge. All right, so the target for our next two lessons are I can use oxidation numbers to predict molecules. Today, I would just like you to be able to identify the oxidation number for each element. And you have a series of questions that follow this video that are going to ask you to kind of predict that oxidation number. And you can use this chart certainly use this chart to help you understand it. All right, please reach out if you have any questions or if something's not making sense. I'm here. We can do a Google Meet, whatever you might need. All right, I hope you guys are enjoying the beautiful weather. I will talk to you again soon.